One last little item. Guys and girls, I know what it's like to have to use the restroom. Don't be like, oh, I'm feeling uncomfortable. Don't go mass exodus, but you have to use the restroom. Take care of business. We're all, well, you guys are closer to being an adult than I am, but that's just me. All right. What's bad about statistics sometimes? Not as accurate? Okay. Let's see. What if I were to have found a study that was out there that said using your cell phone nonstop is good for your health? What if I found another study, looks like the exact same study, that says using your cell phone nonstop is bad for your health? Which one are you going to buy into? Be honest. Which one do you buy into? Yeah, absolutely. Why is that? Because it fits right along with your beliefs. What do you think? You would hate for someone to tell you your cell phone is bad for your health. Why is that? Because your cell phone means so much to you. And I would imagine most everybody in here has some sort of mode of communication as far as a cell phone goes. Right? If I found a study that said starting high school at 10 o'clock in the morning is good for your health, you're all in, aren't you? Why is that? Because, dude, I want to sleep in. Pediatricians will tell you flat out, it's not healthy to start high school early. Huh. What would happen if we started high school at 10 o'clock in the morning? No, 5. Where would those extracurricular activities take place? I had practice last night till midnight. Damn. So, sometimes you might see something in statistics that it falls right into your beliefs, and you're going to support it right away. Sometimes there'll be something out there that says we should start high school at 5 o'clock in the morning. That can't be good for you. But it falls against your beliefs that I want my sleep. So probability statistics, I will refer to Vegas a lot because I understand probability statistics. I understand how gambling works. I will teach you, if you'd like, to count cards. It's not all that hard. No, you won't beat the casino because you don't have a bankroll large enough to beat the casino. Okay, I understand some of you come from a little bit more affluent backgrounds of your family, but still. When I lived in Vegas, first year I was in Vegas, they hired 4,500 teachers to Clark County. Clark County, Nevada, which is Vegas, Henderson, North Las Vegas, was the most rapidly growing county in the United States. It was the most rapidly growing school district where they were opening one school, whether it was elementary, middle, or high school, every 30 days. That's how rapid it was growing. So I moved there, and they decide, hey, we have an idea for a beautiful resort called the Bellagio. You guys with me on this? At the Bellagio, they decided, we're going to put a 17-acre water park out in front of it. The people are going, where's this water come from? Lake Mead. Well, where's the water from Vegas come? Lake Mead. What's really down because snowpack in the Rockies was down? Lake Mead. But they're going to put this there. Bellagio is $1.2 billion when they built it. It opened on a Thursday. 75 armored cars showed up 2 weeks earlier to deliver the coins alone to the Bellagio. Bellagio opens on a Thursday. By Sunday night, the news in Vegas said the Bellagio has now paid for itself in full. It made $1.2 billion in profit the first 3 days it was open. Now, I get it. It's exciting. It's a brand new casino. People were flocking there. You'd walk into the Bellagio. Yes, I went on opening night because I was that guy. I got to see what's so special about this. And every blackjack table, every craps table, every baccarat table, every slot machine had a line of people waiting to play. Yeah, they make it more fun on those opening nights because it's like, hey, we're going to have celebrities walking through, and we're going to have fancy shows, and we're going to give, like, you know, a car away every 7 seconds. It was exciting, and it was packed. It was paid for from Thursday night to Sunday. Paid for over $1 billion in profit. It's a lot of money. So what does Vegas do, or a casino do, that isn't right? Does this. Take a very simple event. Let's flip a coin. Okay? We've all flipped a coin or seen some sort of coin toss. Call it heads or tails. For all intents and purposes, it will not land on its edge. You always do one kid. What if it lands right on its edge? What do you call it? Well, it's a rethrow. Whatever happens, take a picture of it and say, look what happened. But this is what Vegas does. Let's say I said, all right, we're going to play a little heads, tails games. If I throw a heads, you can bet $1 to win 30 cents. If I throw tails, you can bet $1 to win 30 cents. So you could lose $1 on a 50-50 shot, but the payoff is less than half. It's not a fair game. The game of craps, which we'll talk about a little bit today, which is a dice game, probability of you rolling a 7 is 6 out of 36. There are 6 different ways that 2 dice can show up on the table to roll a 7. That's a 1 in 6 probability. The payout on that is far less. You can bet on any 7 coming up. The payout on it is about 5 to 1, even though it happens more often than that. So they win because they've changed the odds that they pay you back on. When I used to live in Vegas, I'd fly back every now and then to Phoenix, which is post 9/11. So I would drive over to the airport. It's like, okay, it's a 4-hour drive home from Las Vegas to Tempe, Arizona, or it's a 1-hour flight on Southwest Airlines. Southwest Airlines at the time was going $29 each way, Phoenix to Vegas. It's cheaper for me to fly to Phoenix than to drive, even though I didn't have to have a car, so I had to steal my mom's Cadillac and drive down there and set up with some dork driving a Cadillac that was bigger than his room. There's always some guy on the plane for Southwest Airlines. I got a system to beat the casinos. If you have a system to beat the casinos, you're not taking a $29 flight. But it's always funny. There's always some guy. He's always the loudest guy in there. Yeah, I figured out how to count cards. I won this time. How much did you win? I won $300. How much did you lose before you won? Oh, that doesn't matter. No, it kind of does. People who gamble will tell you about how much they've won. My biggest mistake my first year in Vegas, I decided to chase a bet. I'm at a casino. I'm gambling, and I loved it, and I was losing money. The buck's got to turn. So I said to the pit boss, here's my credit card. Can you pull $3,000 off that, please? Absolutely, sir. Boom, $3,000 in chips. 28% interest on the money. Took me a year to pay it back. Sucked. I'm making $25,000 a year as a first-year teacher many years back in Vegas. Just dropped $3,000 on a credit card, thinking, luck's got to turn. My friends would come up from Arizona, dude, let's go to the casino. I'd go and I'd watch and hang out. I'd count cards and I'd tell them when to hit. But I wasn't gambling because I didn't like the $3,000 it took against me. So let's take a look at this first page of our notes. It says experimental, empirical probability. This is based on observations. If you're watching a bunch of things take place, you might be able to make a conclusion. You wake up each morning, you look off to the east, and you see the sun coming up. You see it enough days in a row, probably pretty safe to say, you know what, the sun's probably going to come up to the east. Or if you're not that early riser, sometimes you're looking at the mountains going, look, the sun's going down over those mountains because nighttime to the west. So, based on observations. Theoretical is based on formulas. Okay? So, experimental and empirical are based on observations. Theoretical is based on formulas. The law of large numbers, pretty simple. You've all seen this. You go to the buffet. Above the roast beef or the chicken table, a little sticker on this little sun-colored light says caution hot. What do y'all do? Touch it. Really is hot. Wet paint? Oh, you gotta make sure it is wet paint. Look, it really was wet paint. Yeah, there's a sign there, you moron. Oh, so we observe enough stuff. Law of large numbers. The more trials, the more accurate your probability. Okay, you're taking a look at dice rolling. You roll the dice over and over and over and over and over again. You do 10,000 trials, 100,000 trials, and you record each time what the sum of those two dice were. You're going to find that the number 7, the summation of those two dice coming up to 7 is more often to happen than any other combination of those dice from 2 to 12. Why is that? It's the highest amount of outcomes that's going to take place is 7. Okay, and sample space is the set of all outcomes. Okay, you've seen this before. So today is Tuesday. Tomorrow would be Wednesday. Let's say Tuesday there was a 30% chance of snow. Let's say we didn't realize that we're going to get dusting overnight. Well, let's say Wednesday has a 10% chance of snow. Does that mean that there's a 40% chance of snow on both days? Create the Venn diagram out of it. This is the probability that it's going to snow both Tuesday and Wednesday. That's actually down to 3%. Complement of event. So you have the probability that an event will take place, and you have a probability it won't take place. So you think complement of event. You have a 30% chance that something will happen. You have a 70% chance that it won't happen. Okay, if you have 1% chance something will happen, you have a 99% chance that it won't happen. So that's the complement. The complement and the event have to add up to be 100%. Single event probability, the number of outcomes you want divided by the total number of outcomes. So single event probability, the number of outcomes you want divided by the total number of outcomes. So a simple thing to think about is you have a number cube, a die. And on this die you have 1 dot, and then you have, let's see, 6 on the bottom. You have 2 over here, and you have 5 over here. And you have 3 over here, and you might not have known this, but on any die, any 6-sided die, the sum of the top and the bottom is 7. Flip the other way. Sum of the top and the bottom, 7. Flip it another way. Sum of the top and the bottom, only 7. So, probability of getting, if you took this die, what would the probability that if you rolled this die, you get a multiple of 3. Okay? So that die you have 1, 2, 3, 4, 5, 6 as your sides. What's the multiple of 3? 3 and 6. So how many different things could show up on a die, a regular 6-sided die? There's 2 of them out of 6. 2 out of your 6 outcomes on this die would result in a multiple of 3. Now, 2 out of 6 is a legitimate answer, but your elementary school teacher was adamant that you reduce your fraction. Which answer is correct? Both. Which one should you use? Either one. Okay? A reduced fraction is not a wrong answer. And I'm sorry that you're indoctrinated by your elementary school teachers that, no, you didn't reduce your fraction. Okay? Let's go through a few examples. You roll a 6-sided die like we have up there. What is the probability of rolling a 1, 1 and 6 outcomes? What is the probability of rolling a 2? 1 and 6. What is the probability of rolling a 1 or a 2? 2 out of 6. Can I reduce 2 over 6 to 1 over 3? Absolutely. Should I? You can. Do you need to? It's up to you. Now they said you roll 2 6-sided dice. So it's a pair of dice. So the plural of a die is dice, if you didn't know that. So we have a 1, a 2, a 3, a 4, a 5, and a 6 on one of the die. We have a 1, a 2, a 3, a 4, 5, and a 6 on the other one. What we're going to do is we're going to sum them up. 1 and 1 is 2. 2 and 1. So you want to understand how I got those numbers? The red numbers represent the summation of the 2 die. And then I get I believe this grid is about halfway down. There's your outcomes. This probability of rolling the sum of 1. Huh? 100%? Can I roll 2 die together, add the numbers up, and get 1? Nope. 0%. 0 out of how many outcomes look like they're up there in the red? A little more than 12. I have 6 rows, I have 6 columns. 36. There's 36 outcomes that can take place on a die. So the probability of rolling the sum of 1, 0 out of 36, which is 0. What is the probability of rolling a 2? How many different ways is I have 2 written up there? 1. You have to roll snake eyes. 1 or a 1. So it's 1 out of 36. What's the probability of rolling a 7? How many 7s do you see up there in red? 6. 6 out of 36. 6 out of 36 reduces to 1 out of 6. Okay, so it says it's helpful to make a chart for your sample space. So that red is our sample space. The row on top is one of our die. The other row, or the other column, is our other die. What is the probability of rolling doubles? That's a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. Probability of rolling doubles? 6 out of 36, which reduces to 1 out of 36. So the diagonal from the upper left to the lower right, so the 2, 4, 6, 8, 10, 12, those are your doubles. The diagonal the other way is all your 7s. All right, let's finish up these notes. We are going okay. Am I going too fast for everybody? I think I have just enough time. Okay, let's talk about a standard deck of cards. You have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Now someone's going to say, I thought ace was bigger than king. It is, but you don't have a 1, so a lot of times an ace is considered to be the 1. How many different suits do you have in a deck of cards? 4. 4 suits. You have hearts, clubs, diamonds, and spades. Okay? Yes, you can find decks of cards that have 5 suits, 6 suits. Okay? But standard deck is 52 cards, 13 cards per suit, 4 suits. So, if I wanted to know the probability of pulling a jack or a king, how many jacks are in a standard deck of cards? 4. How many kings? How many jacks and kings? Out of how many cards? So 8 out of 52 is your probability that you draw a jack or a king. What about a king or a diamond? How many diamonds are on the set of cards? 13. Is one of those a king? How many more kings are in there? 3 more. So I have 13, which includes a king, and then 3 more. So that's 16 out of 52 probability of drawing a king or a diamond. Okay, don't count the king that's in the diamonds twice. How about a king and a diamond? How many king and diamonds are there? 1 out of 52. How about a king and a jack? 1 draw. Can I get 2 different cards in 1 draw? No. What's the probability? 0 out of 52. A king and a red card. How many red cards are there? 26. How many more kings are there that aren't red? So we had 26 other red cards. 2 of those happen to be kings, right? And then we have 2 more kings. So we want to draw a king, in which there are 4, but 2 are already red. And we want to draw a red card, in which there are 26. So we're going to say there's 28 out of 52. And, oh, excuse me, I just goofed that up. Yeah. There's 52 cards. We want it to be a king in red, so there's 2 out of 52. Sorry about that. So the next page says Worksheet 1.1. It goes 1 through 8, and then on the back side it goes up to 11. Homework for tonight. Sound good? Can you guys make it over to Bare Necessities to find this cool-looking green book that we put together for you? I think it's like $4, I think. If you have a financial problem to it, let me know. You don't have to grandstand in front of the class. Let me know. No one ever has to know. Okay? But if you could, get this by tomorrow. And have a great day, everybody. It's great seeing you.